We've talked about concentration sort of in general terms. Now we need to talk about it in more quantitative terms. So when a solution is concentrated, it's got more solute in it. How much solute is in there? So we need to specify solution concentrations. There are many different ways of specifying solution concentration. Which one is used depends on the situation, because some are more convenient for a given situation than others. So one method of specifying is the concentration is mass percent. So mass percent, it's the number of grams of solute per 100 grams of solution. So this falls right in line with what the definition of percent is. Percent is the part over the whole. So percent is the grams of solute divided by the grams of solution times 100, which is the part that you're interested in divided by the whole thing times 100. So what it's important to remember is that the denominator here is the mass of the solute plus the mass of the solvent. So if you're making a saltwater solution, it's the mass of the salt and the water. It's the mass of the whole solution. There will be a tricky question where I give you the mass of the solute and the mass of the solvent and ask you to calculate the mass percent. You have to remember to add those together for the denominator. This material is on the next exam, not the one I'm giving today. But you've been warned, I will try to trick you on this one, okay? It's the whole part that we're interested in divided by the whole thing. It's a mass percent, and so we're looking at masses. Calculate the mass percent of a sucrose solution containing 11.3 grams of sucrose and 412.1 milliliters of water. Assume that the density of water is 1 gram per milliliter. So we've got two numbers here. We've got 11.3 grams of sucrose, and we've got 412.1 milliliter and write gram, milliliters of water. We're asked for mass percent. So the mass percent here of sucrose is going to equal the mass of sucrose divided by the grams of the solution, the whole thing, times 100. So they gave us the mass of sucrose, 11.3 grams, and then we need to calculate the mass of the solution. We don't want to divide by the mass of the water. Well, they didn't give us mass of water, but they gave us milliliters of water and told us to assume this density. So converting mass and volume using density is a very important type of calculation to know. The density is just a conversion factor. I've got milliliters, I want grams. So I'm going to multiply by something with grams on the top and milliliters in the denominator. That converts milliliters to grams. I need the density for that. It happens to be exactly 1 here, so the math is pretty trivial. It's 412.1 grams of water. But for the mass of solution, I have to add those together. 11.3 plus 412.1. 11.3 plus 412.1, 423.4. And then times 100. So 11.3 divided by 423.4 times 100. I look at all my math here. I've got 3 significant figures. 2.66, that's my third significant figure. Write down 2 extras. And then that's going to round to 2.67%. Any questions? Mass percent is used a lot in medicine and biology and stuff because it's very easy to make a mass percent solution. You just use the balance, and so it's a lot easier than some of the other units that we're going to see. Any questions? So other related units, parts per 100 is the same as percent. Parts per million, ppm, is grams of solute per million grams of solution. Parts per 100 is how many grams per 100. So you take the part divided by the whole times 100. Parts per million is the part divided by the whole times a million. And parts per billion is the part over the whole times 1 billion. And these are just used for much smaller concentrations. These are used in things like, measuring levels of contaminants in drinking water. It's going to be on a very, very small amount, but maybe the lead in the water is 1 part per million. Mass percent, as just like percent composition, can be used as a conversion factor. So you've got the mass percent, like we just calculated, 2.67%. That's grams of solute per 100 grams of solution. So if we wrote that out, that 2.67% that we just calculated, we can write that as 2.67 grams of solute per 100 grams of solution. So in that case, it was sucrose, and this is the mass of the whole solution. So that allows us to convert between mass of solution and mass of solute. So how much sucrose in grams is contained in 355 milliliters of a soft drink? That's 12 ounces. Containing 11.5% sucrose. Assume a density of 1.04 grams per milliliter. So we've got 355 milliliters. And we've got 11.5% sucrose. And then we've got this density. 11.5% sucrose. That's 11.5 grams of sucrose per 100 grams of the solution. You can write any percent that way. So what are we trying to find? Grams of sucrose. So let's make a little path here. Oh, I'll put the path down here. So we're going to start with something, and we're trying to get to grams of sucrose. That's what we're trying to find. We have to figure out what are we starting with. We look at the numbers that we're given. This is a volume, and this is a conversion factor. So we're starting with the volume of the solution of the soda. So 355 milliliters of the soda. Oops, that was not the eraser. The soda is the solution. Can we go directly from milliliters to grams here? We have a density. What is this density for? It's for the soda, right? 100 grams of soda, 1.04 grams of soda per 1 milliliter of soda. We can't use that to convert to grams of sucrose. but we can use that to convert. This is just really horrible planning on my part. Okay. We can use that to convert to grams of solution. And then we use the percent composition to go from grams of solution to grams of sucrose. Any questions about that? That wasn't very good. So I've got 355 milliliters of solution. And I need to go to grams of solution and then to grams of sucrose. Apparently my handwriting has deteriorated over the weekend. So grams of solution to milliliters of solution, that's the density. 1.04. Milliliters of solution cancel out. Relating grams of sucrose to grams of solution is the percent composition by mass, the mass percent. So 11.5 grams of sucrose in every 100 grams of soda. So 355 times 1.04 times 11.5 divided by 100. $42.458 grams. And rounding to the correct number of significant figures, 42.5 grams of sucrose. That's a lot of sugar. Can of soda. Any questions? Dimensional analysis again. Why do you think the density of the soda is higher than just pure water? Because what's in the water now? Sugar. Put sugar in the water, and it makes it way more. Any questions?